Welcome to our first video. In this video we're going to start exploring the concept of a limit, and we're going to use our calculator and use technology to estimate what a limit is. First of all, what a limit, as f of x becomes arbitrarily close to a unique number, that's L, as x approaches a value of c from one side or from another side, and that's called a limit. This is the way we write it right here, and that's called, it's read as the limit as x approaches a critical number, as the x approaches c, of f of x equals L. The L value will be a y value, or f of x value. In our first example, our first couple of examples, what I'm going to do is I'm going to explore, okay, well, if I had the limit as x approaches 2 of 3x minus 1, which is just a line, there's no restriction on this line, so we could just plug in 2. If we plugged in 2, we would find that this limit would be 4. If I use my table of values, which is kind of what I'm doing in this first part here, what I can see is that as x gets closer and closer to 2 from the bottom and from the top, what we call a sided limit. This would be the left-sided limit. This would be the right-sided limit. Then the y value converges to 4. And so that would be, the answer would be 4 right there. In our next example, now we're letting as the limit as x approaches 0 of this expression right here. I can't just plug in 0. If I plug in 0, I'm going to get 0 divided by 0, and that's undefined. We don't look at things that are divided by 0 in this class. So therefore, we can evaluate this on our calculator. And what I'm trying to do is I'm going to go from the bottom side, and I go from the top side as x approaches 0 from below, and as x approaches 0 from above. So this is my right-sided limit. This is my left-sided limit. My y values are converging closely to 2, so this limit is 2. I'm going to show you in our next video how to solve this problem algebraically without your calculator. But in this first video, what we're going to do, or in this first assignment, what we're going to do is we're going to be using our technology, we're going to be using our calculator to evaluate these limits. In our third and last example, this time I didn't create a table for you. I want to show you how to do that on your calculator. We have the limit as x approaches 1 of this expression. Again, you can't just plug in 1 here, because if I just plugged in 1 here, I would get division by 0. Division by 0 is undefined, and we don't deal with that in this class. So what I did was we're going to put this in our calculator. So if I put it in my y equals, equation. Okay, I just typed in that equation. And then what I'm going to do is I'm going to take and I'm going to change my table settings. So if I go up here to table set, and then I go down to where my independent variable is, and I change that to ask, now when I go to my table, it's blank. And what this allows me to do is it allows me to type in values that are just below 1 and just above 1. So let's get close to 1. So let's go 0.999, and let's enter that, and we are pretty close to 2. And so then we go 1.001, and we're still a little bit over 2, so I'm going to say this limit is 2. And believe it or not, that's all you need to do in this first assignment. So we're going to be taking a look at introducing you to limits, what a concept of a limit is, and then using your technology to estimate limits. Good luck.